Hello 172 class, and welcome to your second lecture video. We're still using the unit circle. Hopefully you recognize that equation from the last video. And what we're going to do here is we're going to talk about a new type of angle measure that you may or may not be familiar with, which is called radian measure. So you're probably familiar with if I took this little black dot and I rotated it around this circle all the way until I was up here on the y-axis from the x-axis. That's an angle of 90 degrees, and you're probably familiar with degree measure. So this is a 90-degree angle here, and then if I rotate it all the way back to the negative x-axis, that would be 180 degrees. Alright, if I rotate it down to the negative y-axis, that would be 270 degrees, or 180 plus another 90. And then if I went all the way back around, that's 360 degrees. So you're probably familiar with degree measures and seen those before. Half of that, if I was halfway between the x-axis and the y-axis, that's a 45-degree angle. So again, hopefully at least you're familiar with degree measure, if not radian measure. Now, what is radian measure? So down here, this is calculus. You don't have to worry about this right now, but what this does, this tells us a formula for what we call arc length. And what arc length is what I'm going to do is in a moment I'm going to rotate an angle. I'm going to start increasing the angle of this little green segment off the x-axis. And what's going to happen is this black dot is just going to color the blue circumference area of the circle, and it's going to color that green. And that's what we call arc length. Yeah, arc length is not just on circles, but on any graph. If you want to compute how far you've traveled along a particular graph, that's called arc length. So if I want to compute the arc length from this black dot, how far it's traveled along the circle based on an angle of rotation, that's what we're going to be talking about here, is how far has that dot traveled. So as I start to move it, you'll notice that we're seeing this right triangle up here. Just a reminder again, we talked about in the last video that right triangles show up a lot in this course. But just notice now the green arc has started to form, so we actually are getting a positive arc length now. So this is arc length S. Again, don't worry about the formula, just notice now we've moved half of a unit. So again, the radius, this is the unit circle, so the radius is 1 unit. So the distance from here up to where the black dot is now is half a unit. Okay, now if I keep moving, I can go all the way around the circle, okay, travel all the way around and get back to where I started. Alright, now what we're considering, what we're interested in with arc length is radian measure. We want to start from, this is what we call initial position, the positive x-axis, and rotate upward until the arc length that we've cut out is equal to the radius of the circle. Now this is a circle, again, a radius 1. Okay, so we want the arc length to be 1. S to be 1. So again, if I rotate up to where S is equal to 1, there's the angle that's created. Now again, don't worry about this down here. This is the conversion from A. A is already in radians, but this is the equivalent measure in degrees. So again, in between the positive x-axis and the positive y-axis, we said right in between would have been about a 45-degree angle. That's half of 90. And we're a little bit beyond that, so you can see we're about 57.3 degrees. Well, that's 57.3 degrees, but that's what we call 1 radian. A here is a radian measure. So 1 radian is when the arc length from here to here is equal to the radius. Okay. Now, had the radius been 2, notice I now have x squared plus y squared equals 4. And remember, that's r squared. So the radius is now 2 units. I just changed this down here to 2 as well. I still get the same angle, 57.3 degrees. So the radius is now 2. The arc length is 2. The thing required to do that. So let me show you if I put back in there x squared plus y squared equals 1. Alright, the old one. Now you can see they're both in there at the same time. So this is a radius of 1, and then if I connect that's a radius of 2, and they're still, it's the same angle right here, obviously, and this is 90, so this is the same angle. So these are similar triangles when the radius is 1 versus the radius 2, and we can see that that equation, it gets this 1. Right, the arc length is 2 for this one, and the radius is 2, and the arc length is, oops, there it is, and the arc length is 1 for the unit circle when we're doing this. And it's what I'm wanting you to see is that it's not unique to the unit circle. Okay, it works for any size circle. Okay, the radius can be 1, it can be a unit circle down here, the purple one, or the radius can be anything. This is going to work. Okay, so the angle that's required to make the radius equal to the arc length, right, arc length and the radius, arc length and the radius, when they are equal, we end up with an angle of about 57.3 degrees, which is about 1 radian. Now, 57.3 degrees, that's not the way we're going to convert it. You know, that's not going to be our conversion. It's close, it's an approximation, but we want it to be exact. So we're going to be smart about it. We're going to think about how am I going to do this. So instead of using some decimal approximation that software is giving us, we're going to use the fact that the radius is equal to 1. And before this class started, you should know that the circumference of a circle is equal to 2 pi times the radius. Well, in this case, because the radius is 1, the circumference is equal to 2 pi. Alright, well, what is arc length other than the distance around, to where we stop? What is circumference? Circumference is just arc length all the way around. So the circumference is 2 pi, and when this is 1, this is 1 right here also. So the arc length is equal to 1 when the radius is equal to 1, or when the, when theta is equal to 1 radian. Alright, so it's very important that we remember that this is 1 radian, is that angle measure right here. So when the arc length is equal to the radius, you are at 1 radian. Well, if the arc length is 1, when we have 1 radian, there's this 1-to-1 ratio between the two. So if I doubled this, and the arc length was, over here somewhere, it's probably a little bit too far, but I'm just trying to illustrate the idea that when I go a little bit further, and I've got to the point where, it'd be about right in there, that the arc length was 2, what angle would I be at? I would be at an angle of, double 57, but more importantly, I would be at an angle of 2 radians. So, arc length is 2, the radians are 2. Well, what if the arc length was 2 pi, meaning the circumference all the way around is the same thing as arc length all the way around? So that would be 2 pi. Well, that means that the radian measure equals 2 pi. And there is our key to doing this exactly. If the theta, if the angle measure is 2 pi radians to go all the way around, well, we know going all the way around is 360 degrees. So there is our key rate between radians and degrees. 360 degrees is 2 pi radians. Right? So that's the way that everybody remembers it, because of or that's the way it usually is brought up or defined, because of the relationship. Everybody kind of knows 360 degrees is a circle, and they know this circumference formula. And circumference is akin to arc length when you go all the way around the circle. So that opens up this, but the way we usually do it the way we actually remember and the way you'll see it in textbooks and online, is to just divide both sides by 2. So instead of 2 pi, we say pi radians, and 360 divided by 2 is 180. So instead of going all the way around, we actually stop right here, and we just say 180 degrees. And instead of saying 2 pi all the way around the circumference, we stop like a semicircumference. Halfway around the circle is pi radians. Okay, so there's our conversion. 180 degrees is the same thing as pi radians. And now we can come up with any angle measure we want. What if I have 90 degrees? Well, I can take 90 and multiply it by 1. And I still got 90. Well, instead of writing it as 1, I'm going to write it as something equivalent to 1, meaning something that's equal divided by itself. The same thing divided by itself. So in this case, I'm going to put pi on top, and 180 degrees, pi radians. I'm going to put RAD for radians, abbreviated. 180 degrees on the bottom. They're the same thing. So what I can end up doing is reducing this. 90 goes into 180 2 times, and I'm left with pi over 2 radians. So 90 degrees is pi over 2 radians. Alright, so what I want you to do before you watch the next lecture is see if you can do the same thing with some other common measures. So 45 degrees, alright, 120 degrees, and let's do 330 degrees. And then let's do something that's not exactly slicing up 90 and adding it to itself. Let's do something like 100 degrees. That's not a perfect factor or multiple of 90. Let's do something crazy like 27.5 degrees. Let's see if you can do all 5 of these before the next video, the 3rd lecture.